Hello and welcome to this video. In this video, we are going to have a basic understanding of VLANs with this very simple network before we move on to more complex scenarios of VLANs with this network. So by default, every port on a switch is configured to the native VLAN, which is VLAN 1. Let me turn my notes on and show you what I'm talking about. Okay, so I'll open the console to this one. So I'll do show IP interface brief to show our interface is available, and there we go. And then I'll show VLAN brief, and as you can see, all the ports on the switch is configured to be in VLAN 1, and therefore when we connect two devices on the same subnet, they can be able to ping each other. I already have some VLANs on. I will go ahead and then delete the VLANs. VLAN 1. Okay, let me keep it on, and now use it for the scenario. Right. So I'll configure this virtual PC to use an IP address over there. And I'll configure this one too. At the moment, PC1 and PC2 are on the same subnet, and therefore they should be able to ping each other. And also they are all in the native VLAN, which is VLAN 1. So therefore the traffic from VLAN PC6 should be able to reach PC5 on the other end. So I will do a ping to PC5, and as you can see, it succeeds. So let's do a live capture to build the foundation or the basis for this complex network over here. So I'll start a capture here. Start a capture here, and I'll start one here. Okay, so I'm going to do another ping. So let's see the capture and see what we captured. I'll start from PC6. I will search for ICMP, and as you can see, this is PC6 talking to PC2. I'm checking on the Ethernet frames. All the frames that is transferred from PC6 to PC5, they are just Ethernet frames. So they are just basic Ethernet frames. So from PC6 reaching to PC the switch over here, the frames that are being sent are just Ethernet frames. Same applies to 5 on the receiving end. The frames are just Ethernet frames. I want you to note this one down. As we go ahead, we will get a more understanding of VLANs. So, since they are in the native VLAN 1, they are able to communicate with each other. What if we switch the port connecting PC5 to a different VLAN? So, I'll open the switch, and as you can see, PC1 is connected on PC6 is on ET00, and then PC5 is on ET01. So I'll go to interface E0/1, switch, access VLAN 2. So at the moment, I'm moving Ethernet 01 from the native VLAN to VLAN 2, and that means PC6 cannot ping PC5 anymore because they are on separate VLANs. And the basic general knowledge in VLANs is to stop broadcast from one port to the another. In other words, it's used for network segmentation. Network segmentation simply means logical separation of networks. So I'll move it to VLAN 2 and I'll drop back. Now show VLAN brief. And as you can see, ET01 is in VLAN 2. Now if I try to ping, it won't work because PC2 is in a separate VLAN. And as you can see, the ping reply comes back with host 10.2 is not reachable, meaning there is no network path to 10.2. So if I decide to move the port 01 back to VLAN 1, I should have the ping working. So I'll do show VLAN brief, and as you can see, there is no active port on either VLAN 2 or VLAN 3. They are all back in the default VLAN, the native VLAN, which is VLAN 1. And then I'll go ahead and try the ping. Okay, and it should work this time around. Should work. Yes, and it's working now. So it's taking time to learn the network path. Right. So in this very simple video, we get to understand how by default every port on a switch is configured to be in VLAN 1, and then when you change the port to a different VLAN, you are just doing network segmentation. You're trying to break the network into various logical networks. So in other words, although they are on the same subnet, but they can't communicate together because they're separate VLANs. So I'll end the video here, and in my next video I'll talk about this complex network and explain more about VLANs and then trunking. Thanks for watching.